Welcome to my channel. In this particular video I will be talking about QuickSort. So most of you may think that by the name itself, I was telling the name bubble sort because it goes as a bubble selection sort. Okay, so we are selecting the elements. So QuickSort may be thinking that it is very quick. That is the reason why we are talking about it saying as a QuickSort. It's not like that actually, but still QuickSort is one of the most powerful sorting algorithm. That's the reason why maybe the word quick has come into picture. Okay, and it is also based on the concept of divide and conquer, right? That what is the sorting algorithm that we have already seen with divide and conquer? Very good, it is a merge sort, right? So merge sort is based on the divide and conquer, and the quick sort also based on the divide and conquer. Now what exactly basic difference between quick sort and merge sort, I will tell you once we complete the quick sort itself. Now how exactly this quick sort works? We have to find one particular element, and that element we call it as nothing but pivot. Okay, and we will, based on that pivot, will partition the entire array into two parts. One part will contain all the elements which value is less than the pivot. Okay, right, and the other part will contain all the elements which are greater than pivot. And if any number which comes which is equal to pivot, you can either put in the left or right, whatever. So you can say like it will be left will be starting from 0 to the pivot itself, and more than pivot will be on the right hand side. Okay, and at the middle that pivot will be on the middle sub array, right? So you can understand that if I have an element of 5 elements, okay, and then I take a pivot. Okay, so and if I have 3 elements which are less than the pivot, so we'll have 3, then we have the pivot. Okay, then we have the right side 1 element which is more than that pivot itself. Now there is also criteria of selecting the pivot. Say like we can say pivot, we can consider the first element. Okay, we can consider the last element of the array, or sometimes we can find out the median of that. Okay, right? So we can take the element average, whichever goes towards that particular element itself. Okay, we can take it a pivot. So mostly we in this particular my discussion I will be only talking regarding the pivot element, starting the first element to be the pivot, so it becomes easy for us to understand, right? Okay, and once we have that partition on the left and right, okay, the same way we going to do this left subtree, again we will consider the pivot element. Okay, and then again we'll partition it, and here also right also we'll take the pivot element, the first element as a pivot, and we will going to partition it. And that what we can do is completely we can do recursively. That what we have seen in the merge sort also, right? Okay, so we are dividing continuously, we are dividing into smaller units and all, but here we are dividing based on nothing but the pivot element. So the pivot element becomes my base to which I am actually dividing. Okay, the pivot will be one particular sub array, and in the middle array and the left will be having elements which are less than the pivot, and the right will be all elements which are more than the pivot. Okay, right? So that's what if I take as an algorithm like that, if I take left is 1, right is n. Okay, if left is equal to n, then I will partition. Okay, and I partitions. Okay, and once I partition based on this p is nothing but I'm talking about the pivot element. Okay, so left to p minus 1. Okay, all are on that. Then we have that ap, okay, which is the pivot element, then ap plus 1 on the right. Okay, then again we applied the quick sort, okay, from the left to the p1, and the quick sort from the right itself. Okay, yes, right? So that's what the part itself, right? So again once we partition, we have to see how exactly we'll shift the elements. So we will consider elements. If the element is less than the pivot, okay, then we will swap it. Okay, right? Yes, and if and then we started incrementing the value of p itself, and then we go. Okay, right? So that's what the entire partition algorithms works at. So like this algorithm will be clear when I'm talking about when I give the explanation itself. Okay, so I don't go through each of this line. Let us go through that example, and you'll understand how exactly it does. Okay, just you have to understand that you will be scanning all the elements, okay, right? And we will try to find out each element which is lesser than the pivot, then we will going to put in the left. Okay, the element which are more than the pivot, okay, we don't have to do anything because it will already be there in the right hand, because we are considering the first element, right? See here, if I take this 30 as a pivot, so everywhere in the right, to his right, will be your greater elements, okay, and towards his left it will be always. Now you cannot have this left here, so that will be some shifting, okay, and this 30 will come in such a position in this array so that all elements from on the left will be lesser and all elements on the right will be greater. So if you look very carefully here, so I have two elements, 45 and 31, right? These are the greater than element, okay, and rest are the left. So you can see that and finally I will get here 30. So here maybe here 45 or 31, whatever, or 31, 45, whatever it is, means these all two elements will be greater than this 30, and here we will have all the elements lesser, less than the 30 itself. So let us try. So now I take this as a pivot, okay, and this is my left, and this is my right, okay. So I will compare these two, okay, right, and I will see whether it is greater than, okay. This pivot element is whether it is greater than 45. If it is greater, that means we're going to shift 45 towards this left, right? So let us, or if it is not, we'll keep it intact like that. So let us say AR, okay. So this AR is now this 45. So if you are looking into that algorithm, is now like AR, okay. If it is less than the pivot, then we're going to shift it and all, okay. So this AR, whether it is less than the pivot is 30, no, 45 is not less than the pivot, so it will be like that. Now I will shift this to here, the R will move to the third, okay. So okay, right. So if you see, let me go back again, you will get confused. So 30, it is not like that, okay. So okay, so it is it is greater, so no kind of shifting itself. Now let us take with 30 and 2, okay. Next we take, this is not happening anything, okay. So where 30, 45 go back to his place, that is what it is saying. Now I move the R to 2, right? I move the R to 2. Now 2, is it less than 30? Yes, okay. See, 2 is less than 30, so I will put 2 in the 30 place. Now I will shift 45 to third and I will place 30, because 45 is greater than 30, okay. Now next, this again, this element, and again if you compare, okay, means we are only shifting the element, okay, right. Next again we see AR less than pivot, it is not, okay. 45 again, it is not lesser, okay. So it will be like that only, okay. Next again I will go to 16. Is 16 less than 30? Yes. So I will put the element 16 in place of 30, and whatever element it is there after 30, I will just shift it. So I shift 45, okay, and then I put 30 in this place. Now I will have, okay, 2 and 16, which is less than 30, and 45 greater than, okay. Same again, 30, 40, 45 again we have, it is not n. Again now I will, if I do this again, it is 45, okay. So same position again. Now I go with 31. So 31, is it less? No, again it will go back to here. Now I will say 7. Yes, 7 is less than 30, so I will put 7. Now you see, I will shift 45 to this position, and then I put 30 here, okay, right. So I shift the element of 45 to the position of that 7, okay. Now I have 30 here. Next again I will check with 45, nothing, okay. Then, okay, not required, okay. Then I will check with 23, yes. Then again I will have to bring 30 to 31, yes. So now we will see 31 is shifted to 7, and then we have here 30. Yes. So now what I have got, all the elements on the left is lesser than the pivot element 30, and all the in the right I have all the elements which are greater than the pivot, okay. Yes, right. So now I will consider this left sub 3, yes. okay, right, and then I will going to consider this itself, okay, right. Yes. So I'm just okay, sorry, I'm going back, okay. So let me, we got this, okay. So let's now again I will take this, again I will take this, okay. I will take this and I will try to find out the, I will implement again the quicksort, right. So I take 2 as the pivot element, okay, and if you see all elements, if I compare, then you will see all the elements are greater than 2, right. So that means what I will going to have is that I will again have no left subarray of 2, okay, but I have the right subarray, okay, okay, this is empty, right, and then I have the right subarray which is the 16, 7 and 23, correct, okay. So next again I will consider 16 to the pivot element, okay. Now you will see I will have one left subarray which will have 17 7, and I will have a right subarray which will have 23, okay. So if I do like this, then I got it, right. So I got this, right. So 7, so 16 is the pivot element now, okay. On the left I have 7, on the right I have 23, okay. Now if you see, this entire element has been the sorted form, okay, completed. Yes, now I will go back to my right, okay. So I have left subarray sorted, okay, right. Same thing, it is showing me I take 2 as the first, the what you say, the pivot element, okay. Then I have the right subarray as 16, 7 and 23, okay. Then again I take 16 as a pivot element, then once I do it, then I get here 2, 17, 16, 23, okay, and this is what is completed, okay. Same thing has been repeated out here, okay, for your convenience. Next we go 35, 45, we take as a pivot element. So once we do 30, 31 will come back, will be lesser than 45, so we will go back, and then we have the, the entire array is completed because there is no element left out. So now if you see, I got all my elements sorted, 2, 7, 16, 23, 30, 31, 45, okay. So that's how the quicksort actually the work, okay. So let me tell you one thing again, okay. So what exactly I am doing is something like, once I take the pivot element, if you go back, I will show you the beginning part, okay. So that's what I take 30, right. So I want all the elements which will be in the left of 30 and right of 30, and 30 will, so now 40, 45 is not happening, so we got it, okay, nothing happening. But when 2 is coming, okay, right, we shift the 45 to the 2 positions and we have 30 out here, okay. Then similarly again, if you see 16, I put in the 30, and again I put back the 45 into 30, and I put 30 itself in the next, in the 6th position, because this is in the left side. If you see, this already is sorted, right. Next again I come, okay, it is not required. Yes, now I 30, yes, sorry, right, 7 I get, right, 7 I got, right. So what I will going to do, 45 I will going to, this is not required, yes. So next I got is 31, it is also not required, okay. And then again I get what, 7, okay. Now 7, yes, less than 30, so I put in 30, and I shift the next element, it is 45 to, okay, 30, and then I put 30 here. Understood, right? Yes. And then again I go back, yes, and then I 30, 40, when nothing happened, then I go for 23 again, and again I 31 I will shift, because the next element that we have. So 31 I'm shifting it to the position of 23, and then I put 30, because each time I am doing, I got this elements as the sorted form, okay. So that's how entire quicksort actually works. So we have a left sub tree with all elements lesser than pivot, and we have a right sub tree which is all element greater than the pivot, okay. So I hope you have understood quicksort. So thank you, do keep watching my video.